Okay, Bismillahirrahmanirrahim. So today we will continue to chapter 2, amplitude modulation. There is another notes on chapter 1, part 2, but I think I will do the video lah for that. Okay. So you need to watch the YouTube channel. The link is in kalam. Okay, chapter 2, amplitude modulation. This chapter 2 will include in test 1. Actually, at the moment, we are preparing the question for test 1. We will discuss about the example in kalam later. So, have you got this notes? Chapter 2. Kat kalam dah ada ke? You all ni dengar ke tak? Yang sebut nama lah. Hidayah. Hidayah ada? Senyap je tu.
Ya saya sir.
Nota dah ada dekat kalam ke? Lupa lah.
Saya tak sure sebab semalam saya tengok nota lain.
Ya. Nanti saya share dalam grup WhatsApp lah nota-nota ni.
Okey sir.
PDF. Okey. Okey ya. Okay. So amplitude modulation chapter 2. Content. This slide consists of 7 subtopic. Basic principle of amplitude modulation. AM waveform in time domain and frequency domain. Okay, and then power analysis. Types of AM, amplitude modulation, double sideband, single sideband, and vestigial sideband. Ada 3. There are 3 types of AM. First is double sideband. We call it DSB. DSB. Second is single sideband, SSB. And the third one is vestigial sideband, VSB. Okay. Boleh ya? The next topic is suppressed carrier AM. And then some brief discussion on transmitter and receiver of AM signal. Okay, next. The learning outcome, the student should be able to write. At the end of this topic, the student should be understand and should be able to first write the equation of AM, time domain equation, and describe how the equation relate to the signal. Number 2, define the modulation index, M, the index. Calculate and measure using oscilloscope and spectral analyzer. So yang ni kita teori sajalah, tak ada practical. Number 3 is the student should be able to describe the effect of overmodulation, and you can understand why that the overmodulation should be avoided. It's not good. Okay, learning outcome, calculate, analyze, introduction. So, anybody have any idea about AM? Siapa-siapa yang pernah baca nota ni? Tak pernah. Nanti you boleh Google ataupun tengok dekat YouTube tu, AM. Amplitude modulation. AM is the process of changing the amplitude. So amplitude modulation is changing the amplitude of relatively high frequency carrier, high frequency, in accordance with the amplitude of modulating signal. So kita ada high frequency carrier signal, satu, and yang ni low amplitude, sorry, high frequency. So low frequency modulating signal ataupun information. Okay, kita ada high frequency, kita ada low frequency. So high frequency ni ialah carrier signal, low frequency ialah modulating signal. Modulating signal also known as information. These schemes are still very popular in such diverse areas as broadcasting and cellular telephone. Amplitude modulation is the simplest and earliest form of transmitters. Okay, so in order to transmit the signal, we need to amplitude. We need to modulate. We need to modulate the signal. So amplitude modulation is one of the simplest and earliest, the basic form of modulation. Okay, AM concept. Okay, so AM ni kita ada low frequency and high frequency, kan? So kita ada, in this case, kita ada modulator. Okay, sorry. Kita ada modulator. This modulator is a device that the function is to modulate the signal. The process of modulation. So kalau tengok kat sini, there is two input into this device. One is input satu, and another one is input dua. Okay, so this is output. Okay, so the first input is information or modulating signal. Kita sebut dia kan. So modulating signal or information is low frequency signal. So the second input is carrier signal, which is high frequency signal. So we can see from here, this is low frequency, this is sine wave. Okay, sine wave. Compared to this carrier signal, this is also sine wave, but the frequency is different. This is a modulating signal having very low frequency compared to this, because you know the frequency is f equal to, we have seen before, 1 over t, right? So so this is t. So the bigger the t, the bigger the t, the smaller the frequency. So this is t is small, so the frequency is higher. Okay, so in this modulator, it receives two input. One is modulating signal and one is carrier signal. So the output is called modulated signal. So the output is modulated. So because of this is AM modulator, because we are in the topic of AM, amplitude modulation, so this is called AM modulated signal. So tengok, signal dia dah berubah. Apa yang berubah ni? Cuba you tengok. Apa beza antara signal ni, modulated signal, dengan information signal ataupun carrier signal? Ini ialah information signal, ini ialah carrier signal. So ini ialah modulated signal. So secara ringkas, we can say that modulation is the process of combining this signal, the information and the carrier. Combine this signal, you become this output, AM modulated signal. Okay, so it has equation. so that you can express this signal in terms of mathematical model. So if for a simple sine wave signal, siapa yang ingat dia punya equation? Macam mana equation dia? Sama saja, simple sine wave is Vm, the amplitude, sine omega t, right? So omega is 2 pi f. So f, ada f kat situ, frekuensi. Okay, so this equation Vc sine 2 pi fct carrier, this is the modulated signal, combine. Okay, nanti detail tu kita akan tengok semula lah nanti. Okay, sekarang ni kita tengok proses dulu. Okay, amplitude modulation. Okay. So this is the information signal, or known as modulating. Dia perkataan dia ada modulating, modulated. So modulating is the information, modulated is the output. Don't be confused about those two. Okay, amplitude modulation, this is low frequency. So you can see this is very low frequency and this is high frequency. Okay, this is a time domain signal, V against T. All right. So this is 1 kilohertz baseband signal. Okay. So baseband is another form, is another name for information or modulating signal. So basically it refers to the same signal, either for information or modulating. So information, modulating, or baseband. Basically it is referring to same signal, which is low frequency sine wave, low frequency signal. Okay, so in this case it has 1 kilohertz. Another one is carrier signal. This one normally it has one name only, carrier. So FC. Okay, so FC is carrier frequency and it has larger frequency compared to modulating signal or baseband. Okay, if the baseband and the carrier is combined, amplitude modulated signal will be generated. So AM signal will be generated. Okay, modulated signal, AM modulated signal. An envelope resembles the original modulating signal. Envelope repeats at the FM and the shape of each half. Positive, negative is the same as modulating signal. Okay, ni ialah basically description for AM modulated signal. The AM modulated signal resemble envelope form. Apa maksud dia? Envelope resemble the original modulating signal. Okay, modulating. So the modulated signal, the output, it has an envelope resemble the originating modulating signal. So the output, you can see this, the signal is this one, and the dot here is the envelope. I mean the imaginary line that resemble the envelope. Okay, so this dot is the envelope. So you can see from this that the signal has changing the amplitude. Okay, macam the first peak is here, the second peak here, the third peak here. So it follows or it resemble the modulating signal ataupun it resemble the information. or it resemble the baseband. So this is the AM modulated signal. So first, envelope resemble the original modulated signal, okay, and then the envelope repeats because at the FM. FM is the modulating signal. Okay, so it has half positive and negative. So here you can see here positive, this is negative of that modulating signal. So this is like an envelope, sampul. Sampul. Okay. Wave and shape of modulated wave is called AM envelope. So this is basically the dot 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 line which resemble the envelope. The envelope resemble the original modulating signal. Dalam oscilloscope line ni tak ada. Cuma kita letak imaginary line yang signal modulated signal ni dia berubah amplitude-nya mengikut mengikut envelope tu. Okay. So dalam case ni, the frequency of the signal is carrying the frequency of carrier signal, FC. Okay. So yang ni the modulating signal. Ini ialah modulating FM. Tapi untuk signal modulated signal AM, the frequency is FC. Okay. So AM envelope, in practice, the ratio between carrier frequency and modulating frequency is usually much greater. Maksud apa? Maksudnya ialah FC over FM, right? The ratio between carrier frequency, FC, and modulating frequency, FM, is much greater. Much greater compared to what? Compared to the example. This example. 10 kilo to 1 kilo. So the ratio is 10, right? So in practice, the ratio is much bigger, much greater. Greater than 10. For example, AM Citizens Band, CB, station would have FC 27 MHz and modulating frequency of in order of 1 kHz. So bukan 10 lah, not 10. So kalau dalam case ni berapa ni? What is the ratio? 27 to the power of 10, 6, right, mega, over 1 to the power of 3. So 27 to the power of 3. 27,000 ratio. Not even close lah. Example tadi 10, ini 27,000. Okay, since there are thousands of cycle of carrier for each cycle of the envelope, the individual signal RF cycles are not visible and only the envelope can be seen. Okay, so because of cycle is too much, then we just see the pattern, which is the envelope. Okay, envelope. So this is the signal as shown as in the oscilloscope. So oscilloscope, if you measure the AM signal, the output from that modulator, it can show this kind of signal as this. The sine wave is too much. The frequency is very high, 27 MHz. Then you can only see the pattern or the envelope. That is the meaning of the statement just now. Okay. So this signal can be represented in terms of time domain and what is another domain? frekuensi domain. Okey. You ada ke ni? Boleh dengar? Ezah boleh dengar Ezah? You all buat apa ni?
Boleh.
Ya. Cing, berapa orang lah ni? Lain-lain tak datang? Ada lagi 4 orang, 5 orang. Kenapa saya tak boleh tengok semua? 3. Ni 12 je. Mana lagi orang? Dekat mana? Tak keluar kat sini. Kat sini ada 18 orang. 16. Okey lah. So, you boleh tengok Okay, full carrier AM, time domain. We know how AM wave look like, okay? So, how the wave look like is look like a envelope. But how we analyze it in terms of mathematics? Matematik macam mana? Can you write general equation of sine wave? Boleh? Boleh tulis sine wave. Sine wave is the common equation that you see in your electronic class lah. Circuit V equal to 5 sine omega t. Kan? So ni apa? Basically you ada kat sini lah Vt kan? Sorry. V t equal to 10 sine 100 t volt. Boleh? Ni sine wave. Boleh? So this is amplitude. This is sine. This is, ni apa ni? 100 is omega. Omega equal to 2 pi f. So ini ialah frekuensi. Frekuensi duduk kat sini lah. Okay. So f equal to 100 over 2 pi. Macam tu. Okay. So frequency can be f or omega. Omega itself is already frequency, which is we call it apa dia panggil ni? Yang dalam unit radian kan? Omega. Apa benda tu?
Rad per second.
Apa benda dia punya nama dia? Omega?
Rad per second kot.
Radian per second. Dia nama dia frekuensi angular frequency kan. Kalau F tu frekuensi lah, tapi omega pun ialah frekuensi, angular frequency. Okay, full carrier time domain. AM is created by using instantaneous modulating signal voltage to vary the amplitude of the modulated signal. Okay, so AM is created by using instantaneous modulating signal. So modulating is FM ataupun VM. Okay, to vary the amplitude and modulated signal. The carrier is almost always a sine wave. The modulating signal can be sine wave, but it's more often to arbitrary waveform such as audio signal. So dalam case sebenar, modulating is not really sine wave. Dalam case, practical case, real problem. Okay, but for simplicity reason, in theory we represent the modulated signal as a sine wave. Okay, macam suara lah, macam our voice kalau kita plot dia akan jadi macam tu kan. So basically we say that this is a combination of many sine waves. So to make it easy, we just make a sine wave and we say this is our voice or the information. Okay, so jangan keliru yang tu lah. The carrier is almost sine wave. The modulating signal can be sine wave, but it's more often arbitrary waveform such as audio ataupun voice lah. However, an analysis of sine wave modulation is very useful since Fourier analysis often allows complex signal to be expressed as a series of sinusoid. So dia kata kalau suara kita tu sebenarnya ialah boleh kita, walaupun dia bukan sine wave, tapi dia sebenarnya ialah a complex combination of various sine wave. Sine wave ni various frequency and various amplitude. So combine dia akan jadi kita punya suara. Tapi susah lah. So dia ambil yang senang je, sine wave. Okay. AM wave equation. So apa ni? So this is AM wave equation. This is the equation for AM modulated signal. So kita kata tadi, modulation is the process of combine. So ini input 1 FM, 1 FC. Signal. So this is modulator. So keluar kat sini ialah output. This equation is here. So we can see that there is the unsur-unsur carrier dan modulating signal in this output. Okay, kita kata dia combine. Dalam kes ni kita boleh kata dia sebagai tambah. This input, this modulating signal tambah dengan this carrier signal become AM modulated signal. So this equation here. So VT equal to EC plus EM sin omega CT. Kau tengok sini ialah this is carrier C. This is modulating signal ataupun suara ataupun baseband signal. The amplitude tambah. Okay, sin omega C. Tapi signal ni berfungsi pada frekuensi omega C, frekuensi carrier, ataupun omega is equal to 2 pi F. So omega C 2 pi FC. So ada FC dekat sini. Ada FC dekat, maksudnya signal AM ni ialah sama, the frequency of the signal is taking the frequency of the carrier. Okay, VT is the instantaneous amplitude of the modulated signal in volts. So instantaneous. EC is the peak amplitude and of the carrier in volts. EM is the instantaneous amplitude of the modulating signal. Omega C is the frequency of the carrier in radian per second. Ini radian per second. So omega equal to 2 pi FC. Ini biasalah you electrical dah tahulah. T is time per second. Okay, time domain. So bila ada T, kita panggil this signal is in time domain. Okay. Lama dah kita ni. So this equation and unmodulated signal. Ni apa ni? So this is before modulation. Okay. Before modulation, ataupun kita panggil this is the modulating signal lah. FM tadi yang masuk ke modulator tu, yang masuk ke modulator ini FC. So FM ni, inilah dia punya equation. VM T equal to EM sin 2 pi F M T. So kalau modulating signal semua M, VM, EM, FM. Apa ni? M is meaning modulating, modulating. So VM is instantaneous value, nilai dia pada masa T. EM besar ni, capital is the amplitude. Okay, so we can write it in form of EM or VM, same. So this value, amplitude, sin 2 pi FM. So FM is the frequency of this signal. Frequency, small, low frequency. So EM equal to VM is the peak modulating signal amplitude, the peak value. Okay, V peak. Or we call it the amplitude, right? Okay, so if given this signal, given this value, the student should be able to write the equation. Boleh? Okay, normally we just give this figure. This is a modulating signal with this maybe some value here, ataupun kita beritahu lah ni berapa dia punya frekuensi and berapa sini, what is the value of amplitude, then you should be able to write this equation. Simple kan? So yang ni tak perlu isi apa-apa. Yang ni just gantikan dengan nilai ni. Dan nilai kat sini, gantikan nilai ni. Ataupun terus. Kadang dia bagi amplitude, frekuensi dalam F equal to berapa Hertz ataupun omega. Omega, you tak perlu gantilah. Maksudnya, this whole value is omega, 2 pi F. 2 pi F is omega. Just put it omega t. So maybe omega is equal to 100. So this equation become Em sin 100t. So 100 is omega. So okay. So this is the modulating signal. So unmodulated means before modulation. Okay. So this is the carrier. The next is carrier signal. Okay, you can see that this carrier signal is very high frequency compared to modulated signal. So this is unmodulated carrier signal described by the following equation. So equation dia sama. Equation sama. So kita masih lagi ada, patutnya ada ni, ada apa? Ada exist lah ni. So this is T. This is V. So this is VC lah, macam tadi. Okay. So for the carrier, all carrying the sign C. C is for carrier. EC, VC, EC dan FC. Itu saja beza dia. So EC or VC is the peak value or the amplitude of carrier signal. This value. And EC the amplitude, sin 2 pi FC. FC is the carrier. So in the previous example, we have seen that FC, one of the value is 10 kilohertz. Now the value given is 27 kilohertz. So the value is much more bigger. Sorry, 27 megahertz. Yes, all right. So the value is much more bigger than the modulating signal. So very high frequency. So you should be able to remember this equation. Atas dengan bawah sama. So the difference is only this, VC or EC. So in electrical, you might have the voltage represented in terms of E or V, right? So E is EMF, V is voltage. It's the same. All right. So what happened during modulation? So during modulation, the signal is combined or is mixed together. So in terms of electrical, the equation becomes AC plus EM sin 2 pi this. Darab. Apa yang darab ni? So ini ialah FC. Ini ialah FM, modulating signal. Okay, where EC plus EM is the amplitude of modulated wave. So ini dah jadi amplitude. The whole signal, the amplitude of carrier plus the whole modulating signal become the amplitude of modulated signal, AM signal. And it's still a sine wave signal, but the amplitude change. Okay, so that's why you can see that the amplitude change. The amplitude always changing according to this information. Information dalam amplitude. The information signal come into the amplitude. entering the amplitude. And so EM become peak change in the amplitude of the envelope. So EM is the change. So if EC plus EM, that is the peak. FM is the frequency of modulating signal. So FM still the frequency of modulating signal. So basically this is the equation for AM signal. Just now we have seen the previous signal, meaning EC plus EM, right? EM campur ni. Tapi ni dah dia kembangkan EM bahagi dalam tu, modulating signal. Okay, so by expanding the equation, okay, so we can always expand, derive the equation. So now you get this equation, AC sine 2 pi FC T plus EM sine 2 pi FM T. Apa ni daripada sini? Okay, this equation, right? Padam sikit. Okay, you can see that this one plus ni darab dengan ni kan? Darab dengan ni. Sorry. Ni. Ini. Darab dengan ni. Tambah dengan ni. Darab dengan ni. Okay, matematik lah. Okay, we have this equation. EC sin 2 pi FCT plus EM sin 2 pi FMT. Lepas tu, ada ni. Sin 2 pi FCT. So, from this equation, we can see clearly that this is carrier signal and this is modulating signal. Okay. So the modulated signal, AM modulated signal is combination of carrier signal and modulating signal. Okay. AM concept. In AM, it is particularly important that the peak value of the modulating signal be less than the peak value of carrier. Nilai amplitude. Amplitude is very important in AM, so that the amplitude of modulating signal is smaller than the amplitude of carrier. So we can say that it is important that EM is smaller than EC, ataupun VM smaller than EC, ataupun AC bigger than EM, ataupun VC bigger than VM. Sorry, ni V. VM less than VC, sebab EC or VC is same. Okay. What happen if not? Then distortion can occur when amplitude of the modulating signal is greater than the amplitude of carrier. So if not, if this is not fulfilled, then it can happen distortion. It can occur distortion. So when distortion will happen in AM, this distortion will happen when EM bigger than AC. Okay. Okay, so AM wave equation. Boleh lagi ya? Sekejap lagi. So AM wave equation. So from the equation just now, we can relate to the envelope. This is the envelope. Okay, we can see that this is the AM signal. And from this, you can derive some equation. Okay, from here, we can see that the peak of this envelope, first is the peak of the envelope is called Vmax. Vmax, the maximum amplitude of AM signal, amplitude of AM modulated signal. So the max is the amplitude of EC plus amplitude of EM. Okay, so Vmax is the combination of amplitude of carrier and amplitude of modulating signal. Okay, first is Vmax plus. So minus Vmax negative is reverse of that lah. So reverse. How you explain? So the minus max is the combination of minus EC and minus EM. Okay, so from here, so you have minus EC plus minus EM. So combine dua tu, you akan dapat minus max. Okay, plus min. Positive min is EC minus EM. Here. Positive min. What is the meaning? The meaning is the minimum positive value of the signal. The minimum positive value of the signal is EC minus EM. Because we know that EC should be bigger than EM. So the difference is the minimum positive value. And vice versa, the minimum negative value is minus EC plus EM minus M. Basically, this is minus EC minus EM. So become plus EM. So this is the minimum negative values of this signal. So you have this Vmax plus, Vmin plus, Vmin minus, and Vmax minus or negative Vmax. Okay. Review question. So this question, I think you should try to solve. Some are with answer, and some the answer is not given. Okay, you should try first. Okay, so in this case, it's given solution. So answer, solution. So this for quiz, we might use this kind of question, but of course different value. We can change this value. A carrier wave with RMS voltage of 2 volt. Tahu apa ni RMS? Root mean square. Frequency of 1.5 MHz. Modulated by sine wave of frequency 500 Hz. Amplitude of 1 RMS. Write the equation for the resulting signal. Okay. So given RMS, so you can change to magnitude, to peak value. Okay, so you find the value of EC and EM, omega C and omega M, and you can get the equation. So you can familiarize with this type of equation, so that if in our quiz you might see this kind of question, but of course different value. Okay, if you already done this, then it should be okay. Okay, the next issue is modulation index. Okay, so why we discuss about the amplitude of modulating and carrier just now? Because it is related to the amplitude of both signal is related to modulation index. So this is another parameter to describe the signal, AM signal. So modulation index is a value that describes the relationship between amplitude of modulating signal. Amplitude of modulating signal is EM, and the amplitude of a carrier. Amplitude of the carrier is EC. Okay. So modulation index M is the ratio between M over C. Modulating factor or coefficient or degree of modulation. So modulation index is EM over EC, right? EM over EC. This modulation index is also known as modulating factor or modulating coefficient or degree of modulation. Nama maksud dia lebih kurang lah. It carry the same meaning or almost same meaning. Modulation index or modulating factor. What is the modulating factor? Modulation index lah maksudnya. Okay, so the equation is always the modulating over carrier, M over C. So from this, we can express this index in terms of percentage. Macam mana? Darab 100. Multiply by 100. So you get modulation index. Modulation index dalam unit, tak ada unit ataupun dalam unit percentage. Ataupun unit percentage. Okay. Okay, that is modulation index. So, apa ni modulation index? Percent of modulation. The modulation index is commonly computed from measurement taken on the composite modulated waveform. The oscilloscope voltage values EM equal to Vmax minus Vmin over 2. The amount or depth of AM is then expressed as the percentage of modulation rather than a fraction. So, normally if you are using the oscilloscope, you will get the modulation index in terms of percentage. Okay, because of the display of the voltage in the oscilloscope. Okay, so this is the signal that you might see in oscilloscope. This is called the envelope of AM envelope. So from here you can see real value of Vmax, okay, Vmax and Vmin. Okay, kita dah tengok just now Vmax plus Vmin plus, this is Vmax minus, and this is Vmin minus. Okay, so this signal shows, this figure shows the peak Vmax and peak mean this peak, and true is this. Okay, same as previous picture. So from that you can derive the modulation index. Modulation index can also be calculated using just now from this figure. So half Vmax minus Vmin over half Vmax plus Vmin equal to Vmax minus Vmin, Vmax plus Vmin. So become like this, blah blah blah. So M also can be expressed in this equation. If you are having this is if you're having this figure, especially when you're using the oscilloscope, then you can use this equation. It is easier to calculate the modulation index. Okay. Okay. Substituting M into AM modulated signal. Apa ni? Okay. So we know that EM, M equal to EM over AC. So substituting this equation, M, this equation, okay, factoring this equation, from this equation you can change to become this equation. And you have M inside the equation. Okay, so dia tak ada lagi EM, ada M. EM ni dah masuk kat luar, ni isi dah keluar. Okay, so Modulation index for multiple modulating frequencies. If you have more than one, two or more sine wave of different frequencies modulating a single carrier, so you can have modulation index for, you have more than one modulation index. Okay, so that two or more sine wave of different uncorrelated frequencies modulating a single carrier is calculated by using this equation. So M is the total resultant modulation index, where you have modulation index 1, modulation index 2, modulation index 3. So if you have more than one modulating signal, you can represent the modulation index as resultant modulation index. Okay, so macam mana? Those modulation index need to be ni apa, kuasa 2, power of 2, then you square root. Macam average lah, ataupun kita panggil dia apa? Average. Resultant modulation index. Okay, so review question, exercise. Okay, you need to do this exercise. Try to do the exercise. Okay, next is over modulation, the last topic. So what happen if modulation index is, what happen if just now we say that it is important that E modulating is less than E carrier, kan? So what happen if this is not happen? So one that might happen is over modulation. Over modulation and distortion. The modulation index should be a number between 0 and 1. Okay, so if EM is equal to EC, so the number should be always less than 1. Ataupun if EM equal to EC, then M equal to 1. Okay, so the good modulation index should be always between 0 and 1. But if the amplitude of modulating voltage is higher than the carrier, if this is not fulfilled, so if this is like this, EM is now bigger than EC, if the amplitude of modulating voltage is higher than the carrier, M will be greater than 1, causing distortion. So M, if this happen, then M is bigger than 1. So when M is bigger than 1, it is called over modulation, and the distortion will happen. Okay, distortion, loss. Okay, if the distortion is great enough, the intelligent signal becomes unintelligible. Maksud dia apa? If distortion is too much, then the information signal becomes unintelligible. Information is no more information. It is become noise. So it cannot be understand anymore. So what happen if over modulation? Then it will cause distortion, and the information signal will be lost. Okay. Effect of modulation index. So you can see the modulation index. M equal to 0, M equal to 0.3, M equal to 0.8, M equal to 1, and over modulation. So over modulation and distortion of voice transmission produce garble, harsh, unnatural sound in the speaker. Garble ni bunyi macam tu, kan? So if over modulation, then there will be noise or garble, harsh, blah blah blah. Distortion of video produce scramble or inaccurate picture on the screen. Okay, so over modulation boleh baca. So ini sepatutnya dalam bentuk video yang you boleh ubah nilai ni. Dalam PDF boleh, dalam PowerPoint boleh, dalam PDF dia tak boleh lah. Patutnya bila you ubah kat sini, dia akan berubah kat sini. Output dia akan berubah. Nanti kita cari yang GIF lah. Okay. So when overmodulation happens, the envelope is no longer the same shape as original modulating signal. So original modulating signal kan dia bersambung, dia cantik kan. So bila overmodulation, signal ni dah jadi lain, dah jadi clipping, putus. Putus. So overmodulation. Overmodulation ni M greater than 1. Kan? Tak salah berapa, mungkin M sama dengan 10 katanya. Kalau 10 dah jadi jauh ni, putus. Tak bagus. Distortion, ada noise. Okay. Okay, I think that's all for today. Ni ada exercise, you kena buat lah. Okay, that's all. That's all. Lama sangat tak boleh. Okay, ada apa-apa soalan? You all diam je kan? Orang pun tak datang habis. Mana yang tak datang ni? Saya punya attendance tak keluar nama. Kenapa? Patutnya ada auto attendance ni. Keluar nama saya je. Okay. Ada apa-apa soalan ke semua orang ni?
Attendance isi dekat mana, sir?
Attendance ni sepatutnya auto ni. Mana pula ni? Kena subscribe pula. Tak apalah, attendance kita ambil lah ni sebab ni dia record. Okay? Ada soalan? Tak ada soalan.
Tak ada.
Okay. Thank you very much. So semua orang kena left ha? Okay, bye-bye. Assalamualaikum. See you in the next class.
Alright, thank you.
Thank you, sir.
Semua
Thank you,
kena
sir.
dia jadi record. Nanti saya akan upload video ni.